In this video, we will cover more practice problems about balancing chemical reactions. If you haven't watched the first part of the video, which has a step-by-step guideline of how to balance the reaction, you can refer to that video by the link below. Now let's get started. I have the following reaction. Acetylene reacts with oxygen and produces carbon dioxide and water. A trick to balance this reaction is to leave the individual elements until last. Now let's stop the video for a few minutes and try to work on it yourself. Hit play when you're ready. Before doing any steps, what I usually do is to define what are the starting materials and what are the products of the reaction. And then I'm gonna make a list of the elements that appear on both sides of the equation. And in this case are carbon, hydrogen, and oxygen on both sides of the equation. Now I'm going to count the number of elements on each compound on both sides of the equation. I have 2 carbon, 2 hydrogen, and 2 oxygen on the left side of the equation, and 1 carbon, 2 hydrogen, and 3 oxygen on the right side of the equation. And now to balance the chemical reaction, I'm gonna use the trick that I mentioned earlier, which is to leave the individual elements until last. In this case, it's our oxygen here. Now I'm going to start by balancing the carbon element. I have 2 on the left side and 1 on the right side. And therefore, I'm going to put 2 as my coefficient for the carbon dioxide compound and 1 as the coefficient for the acetylene compound. After that, I'm going to recount the number of elements that I have. I still have 2 carbon on the left side and 2 hydrogen. On the right side of the equation, I now have 2 carbon. And instead of 3 oxygen, I now have 5 oxygen elements. 4 oxygens are from the carbon dioxide compound and 1 of them is from the water compound. I have 2 hydrogen on the left side of the equation and 2 hydrogen on the right side of the equation. And therefore, I'm going to put 1 as my coefficient for the water compound. And because of the coefficient is 1, I didn't affect any of the elements in my compound. So I still have 2 hydrogen on the right side and 5 oxygen on the right side of the equation. Now let's move to our last coefficient here. I have 2 oxygen on the left side of the equation and 5 oxygen on the right side of the equation. In order to have the same number of elements on both sides of the equation, I'm going to put 5/2 as the coefficient for the oxygen compound. And 5/2 is equivalent to 2.5. 2.5 times 2, which will give us 5 oxygen compound on the left side of the equation. However, when we are balancing a reaction, we don't want our coefficients to have fractions or decimals. To solve this problem, we will multiply each coefficient in the reaction by 2 and then check if the reaction is correctly balanced by recounting the number of elements in the reaction. And as multiplying each coefficient by 2, each compound in my reaction now will have a new coefficient, which has a ratio of 2, 5, 4, and 2. And after you recount the number of elements in the reaction, you will see that the reaction is correctly balanced. I have another reaction. Sodium reacts with water and gives us sodium hydroxide and the hydrogen gas. I have a few tricks that you can use to balance this reaction. The first one is to start by balancing the elements that only appears in one compound. And in this case, we see that the oxygen compound only appears once on both sides of the reaction. And another trick that you can use is when you get stuck, double the most complex compound and start over. Now let's stop the video for a few minutes and try to work on it yourself. Hit play when you're ready. As mentioned in the previous example, I have identified the compounds that are my starting materials and the ones that are my products. After that, I have a list of elements that appear on both sides of the equation. And here are the number of elements that I have counted. Apply the first trick that I have mentioned before. I'm gonna start by balance the oxygen element. I have one on the left side and one on the right side of the equation. Therefore, I'm gonna put one as a coefficient for the water molecule and one as a coefficient for sodium hydroxide. After that, I'm gonna recount the number of elements that I have and realize that this is the dead end. I can't balance the reaction any further. Therefore, I'm gonna apply the second trick here, which is to double the most complex compound and start over. So I'm going to remove all of my previous coefficients. In this case, the water compound and the sodium hydroxide compound are the most complex compound. So I'm going to choose one. And I'm going to choose water this time. So I put 2 as the coefficient for water. I recount the number of elements that I have. I have 4 for the hydrogen element and 2 for the oxygen element. Now I'm gonna start balance the reaction like usual. And now applying the first trick that I have introduced, I'm gonna balance the oxygen element. I have 2 on the left side of the reaction and 1 on the right side of the reaction. So I'm gonna put 2 as the coefficient for the compound that contains the oxygen element on the right side. And I'm gonna recount the number of elements now. I have 2 sodium, 2 oxygen, and 4 hydrogen. Now I'm going to move on by balancing the sodium element. I have 1 on the left side and 2 on the right side. So I'm gonna put 2 as the coefficient for the sodium compound. And after recounting the number of elements, I have 2 sodium elements on the left side of the equation. And the last step is to balance the hydrogen element. I have 4 hydrogen on the left side and 4 on the right side. So I'm gonna put 1 as the coefficient in front of the hydrogen gas compound. And after that, I'm gonna check if my reaction is correctly balanced or not by recounting the number of all of my elements. I have 2 sodium on the left side and 2 on the right side, 4 hydrogen on the left side and 4 on the right side. And I also have 2 oxygen on the left side and 2 on the right side. Therefore, my reaction now is correctly balanced. For more practice problems, you can refer to the WTC handout or the Chemistry 110 website with the link down below. Thank you for watching and good luck.